Okay, so in this question, we've been told that we've got silver iodide, right? So, in this context, AgI does not mean artificial general intelligence. It's silver iodide. We've been told that silver iodide reacts with Na₂S, which is, in fact, it's sodium sulfide. And we've been told that the Na₂S is in excess, right? And that reacts to produce Ag2S, sulfur sulfide and NaI, right? Okay, and we've been asked to calculate the mass of Ag2S produced from the reaction. Now, in terms of calculating the Ag2S mass, we would be using the equation mass is equal to number of moles times the molar mass, right? But here's the thing, we don't have the number of moles, even though we could work out the molar mass from the periodic table. So given that, how are we going to work this one out? Well, the way I'm going to approach this is I'm going to look at the ratios, the stoichiometric ratios in the equation. And that tells me that, well, we can use the amount of substance of something else in the equation if we have the known amount of substance to then work out the mass of Ag2S. And we've been told the mass of AgI, and we can work out the molar mass from the periodic table, so we can kind of start from there. So let's start from there. So AgI, we've been given a mass of 17.98, but we have not been told the molar mass. We can work that out though, so let's work out. So MR of AgI, right? Again, this is not artificial general intelligence. The MR of AgI is equal to so silver, you can see on here, these are just excerpts from the periodic table, but silver, you can see 107.9 and iodine 126.9. okay, so that's going to be effectively 107.9 plus 126.9, right? Which is, if you work that out, you should find that you get 234.8 as the MR in that case, right? Now, what do we do with this? Well, what we need to do is, and if I just add the units before I move on, that's going to be in grams per mole. Okay. Right, so we're trying to work out the amount of substance here. And what we saw in the equation was that M is N times MR. If we rearrange this for moles, simply by dividing both sides by the MR, we get that the number of moles is equal to the mass divided by the MR, okay? Which in this case is going to be 17.98. And to be clear, this is the mass of AgI, right? So divided by 234.8, okay? So if you work that out, this will give you the number of moles that we will be working with. And so that gives us 0.0765758, okay? And that's going to be in moles. Now we've got this value, but we need to use the balanced equation to work out, well, what does that mean for the amount of substance of what we've been asked to look at, which is the silver sulfide, right? Well, let's create a ratio. So the number of moles of AgI compared to the number of moles of AgI Na₂S, right? The equation tells us that we've got 2 AgI, and then next to the Ag2S, the coefficient is effectively 1, right? It's not a written coefficient, but we can infer that the coefficient is 1, which means our ratio here is a 2:1 ratio, which means that for every 2 moles of AgI, we've got 1 mole of Ag2S. And what this effectively tells us is that the number of moles for the Ag2S is going to be half what we've been able to work out in terms of the AgI moles. So therefore, the number of moles of Ag2S, let me just put this back. Given this is the moles we did work out, is going to be equal to 0.5, which is, as you know, this is 1/2. So 0.5 multiplied by 0.0765758 moles. Okay, and that is then going to give you 0.0382879, and that's also going to be in moles. So if we look back at what we've been asked again, we've been asked to work out the mass of Ag2S. So we've got the moles now, and again, looking back at the same equation, so now we do have the moles. Before, our difficulty was that we knew we could work out the molar mass from the periodic table, but it was a question of, well, we need to work out the moles as well. Now we've worked out the number of moles, but we haven't quite yet obtained the molar mass or worked out the molar mass from the periodic table. So let's do that now. So we're looking at the MR of Ag2S, okay? So that's going to be equal to, so start with the Ag, that's going to be 107.9 multiplied by 2, and then we add that to, for sulfur, you can see this is going to be 32.1, okay? So plus, and there's only 1, right? So it's going to be 32.1. So that's equal to, and so I'd invite you to have a go working out what that is. But if you do that, what you should find is that that's going to be 247.9, okay? And that's in grams per mole. Okay, so let's actually refer back to, as we said, the M is the N times MR. So we now have both values. So what we can do is say, therefore, the actual mass now of Ag2S is equal to, then we take our molar mass value, so 247.9, and we multiply that by 0.0382879, okay? And so if you have a go at that, that's going to tell you what our mass is going to be, and that's going to be 9.4915801 grams, right? So we've got a mass figure right now. However, again, let's remind ourselves that the question is specifically saying, give your answer to a maximum of 2 decimal places, right? So we need to refer back to this and say, well, we need to get this to 2 decimal places. So that's therefore going to be equal to 9.49, okay, grams to 2 decimal places. Okay, so in this case, this would actually be our answer for the mass of AgI Na₂S.